Now, I want to perform the Novo design of antibodies. First, I find the corresponding prompt and click on it. The agent will attempt to recognize the user's intent and then initiate the corresponding process. Here, the user can also choose to interact with the agent using natural language. Now we have entered the process execution page. In this page, the top left corner shows the execution status of the entire process, the bottom left corner displays the agent's thought and execution process, and the right side records important information about the interaction between the user and the agent. Now I will input the corresponding options based on the agent's prompts. Here, I have chosen the method of designing antibodies based on the target name. I'm going to design an antibody for the CD73 target. Therefore, I will input the CD73 target name here to query its corresponding information in UniProt. Now we have obtained the UniProt ID based on the target name. By scrolling through the information displayed on the web page, we can check the detailed information corresponding to each UniProt ID to determine the target UniProt ID. Then we fill the selected ID into the input box. Now we have obtained the structural information corresponding to the UniProt ID entered by the user. We can view the detailed information of the structure by dragging. Next, we need to select the antigen structure that we will use for epitope conformation in the future, and fill in the corresponding PDB ID and chain ID into the input box. Now the agent has obtained the antigen structure specified by the user and displayed it on the web page. We can download the structure file by clicking on the link below, or we can view the structure information by dragging. By reviewing the structural information, we need to further identify the central residue of the epitope. This residue will become the physical center of the future epitope. We can select multiple residues and choose one of them as the epitope during the final conformation. Now, we need to enter the numeric IDs of the epitope residues into the input box. The epitope segmentation is now complete. We can view the patch information through front-end interaction. Now we need to select a patch for downstream antibody design. Now, the database will be searched to determine if there are any antibody structures that bind to this epitope based on its structure. Next, representative antibodies will be searched from the internal database, and an AI model will be used to identify antibody sequences that may bind to the target epitope. Next, epitope prediction will be conducted. The epitope prediction AI model can determine which antibody V gene regions are more likely to bind to the target epitope. These antibody sequences will then be selected for further CDRH3 design. The V gene sequences of antibodies that are highly likely to bind to the target epitope have now been selected. You can view the sequence information by dragging. These sequences will be used for the generation of antibody CDRH3. Next, the length distribution of the generated antibody CDRH3 will be analyzed, and the distribution of amino acid residues for different lengths will be analyzed and displayed in a chart.